For this video, I'm going to look at number 11 and number 13 with you. So number 11, we're telling whether or not it's linear. So a linear function means it makes a straight line. So it's really easy to look at a graph and know whether or not it's linear. So G is clearly non-linear because it does not make a straight line. On the contrary, I is linear because it is a straight line. All right, when we're looking at our equations, that's probably the toughest to tell. And you can see here, this was supposed to print with the square root of x. It just didn't get printed that way. But in order for it to be a linear equation, it needs to be able to be written in the form y equals mx plus b. So basically, we need a y with an exponent of 1, an invisible exponent there, and an x with just a normal exponent of 1. If it doesn't have an x, that's okay, but it must have a y. So b is linear even though it doesn't have an x, because this is like saying y equals 0x plus 4. It can still be written in y equals mx plus b form. D is also linear because we can subtract 2x from both sides, and then we would be able to write it in slope-intercept form, or y equals mx plus b. So it is also linear. Neither A nor C are linear though, because in A, the x has an exponent. Whenever the x has an exponent, other than just an invisible 1, it's not linear. It would not make a straight line if we were to graph it. And here we have a square root of x. It's not a normal x, therefore it's non-linear. To look at charts and tell whether it's linear or nonlinear, we check the slope or the rate of change. If it has a constant rate of change, it's linear. But if it does not have a constant rate of change, then it is nonlinear. So let's look at E. If we look at our x values, this goes up by 2, up by 2, up by 2. So because our x values went up by the same amount each time, in order for it to be linear, our y values need to go up or down by the same amount each time. But our y values, they go -3, down 3, down 3. So because both our x's and our y's go up or down by the same amount each time, it means our rate of change is -3/2. So this is linear, because it has a constant rate of change. Let's look at F next. If you look at your x values, we're going up by 2, up by 2, and then down by 2. So right away we can see that these are not constant, but that's okay. As long as the same thing happens over here in the y's, we can still be good. So our y's go down 2, down 2, and down 2. So right here, my rate of change is -2 over +2. Here, it's -2 over +2. But here, it's -2 over -2. So because this last set has a different rate, this one is non-linear. It has to be the same for every set of data. All right, and so looking at H, we go up 3, up 3, up 3 with our x's. So if they're all going up by the same amount, that means our y's need to be going up or down by the same amount. We go up 3, up 1. Well, I don't even need to look at the last one, because already I see this rate is 3/3. This rate is 1/3. It has different rates of change, so this would be a non-linear function. All right, let's go ahead and look at 13 real fast while we're on this page. So it says the linear function m equals 50 minus 9d represents the amount m in dollars of money you have after buying DVDs. So we don't know how many DVDs we're buying. That's our independent variable though, because the amount of money you spend depends, the amount of money you have depends on how many DVDs you buy. So the money depends on the amount of DVDs you're buying. All right, so if you're setting up your chart, your M is your dependent variable, your D is your independent variable. So we're gonna list that first. Excuse me just a second. And I make this little XY chart to help me out a little bit. We don't know how many DVDs we're buying. We need to find the domain and range. Well, we know domain stands for DVDs. And we know we can't buy a negative amount of DVDs. So D is going to start with 0 because we can buy 0 DVDs. You can choose not to buy any, but you can't choose to buy a negative amount. So if we plug in 0, what this means is if you don't buy any DVDs, you have $50. All right, so let's see if we buy 1 DVD. So we're going to plug in a 1 for D. So we have 50 minus 9 this time. So if you buy 1 DVD, you only have $41. What that tells me is each DVD costs $9. So 2 DVDs. If we buy 2 DVDs, we have 50 minus 18. We have $32 left. So we're going to keep going, and you have to ask yourself, are we going to be able to keep going and going and going forever and ever and ever? Let's see, 50 minus 27, it's 23. And so the answer to that is no, we can't go on and on forever because eventually our money is going to run out. So we're going to know when to stop when our money runs out. So let's see, if we buy 4 DVDs, that's 50 minus 36. That's $14 left. And notice you cannot buy half of a DVD. So this is a discrete function because we can only buy a specific number of DVDs. We can count the numbers. So let's see, if you buy 5 DVDs, you have 5 left. Well, we know the DVDs cost $9. So if we try to go up to 6 DVDs, we get 50 minus 54. Well, that's negative $4. You can't spend more than you have. So 6 didn't work. So our domain here, the number of DVDs you can buy 0, 1, 2, 3, 4, or 5. 6 was too many. You can't buy negative DVDs, and you can't buy half of a DVD or a fourth of one or whatnot. And so your range is just the numbers that represent how much money you have left. So it'd be 50, 41, 32, 23, 14, and 5.